Okay, hello people. So in this video, I'm going to be talking about the projects that I have been working on recently, and I will go through them and try to explain. Most of them are still in progress, but I have like a pretty interesting idea that I want to share that I have implemented in my projects, and I hope it's going to be educational and interesting. So I was working on Golang because I really enjoyed this programming language, and it's simplistic, but at the same time it's very powerful because it has all the packages that you need, and if you don't have something, you can build it on your own, right? And yeah, so the first program that I have been working on is a chat written in Go, and I'm not going through the chat today. I will do it later since it's a bit bigger application. It has a lot of like things in it, and I will go through it a bit later once it is complete. But I want to mention that the chat uses multiple backends. For example, for storing messages, channels, the user data, etc. So it uses the Redis and it uses in-memory storage. And I was thinking about, okay, is it possible to implement my own implementation, my own version of Redis, and at least sketch it out, and like so I have basics working, and then I can add some additional functionality in the future, and that's what I want to talk about today, right? And this is another project which is a key value storage, like a remote key value storage, which I will use in the chat later. So I can briefly show you that here is the small, like a service application, and the small service, and this is the key value storage. And for those who don't know, it's basically the remote in-memory storage. So you can make an HTTP calls, or you can invoke a remote procedural call and put some data into the storage and fetch some data from the storage, right? And I'm planning to use this implementation in my chat application because I want to support multiple backends. For example, not only Redis, which costs a lot, but for example, my own implementation, right? And that's what I have been working on. So I'm not going to take a lot of time, and as I said before, I will put link in the description, but I will go through the code briefly, and I hope maybe it will take yeah, 20-30 minutes, but okay, so let's go. So first of all, I want to show you how it works. So I have let's clear a couple of windows here, and let me check whether I have some Docker containers running. And I don't know whether you can see the screen. I will make it bigger a bit. So what do I have here? This is like the root folder of my project, and I want to build my service, so I'm running the command already built, but I will bump the image version. So it's going to be 1.1.1, bump in the patch version, and I will build the image of my project, and I will go through the Docker file as well, so you can see how it all works. And I'm going through like it step by step, so you can follow along at home and do everything on your own in order to test the application. So the image is built, and then I have to run, and obviously I have all the commands already because I have been working on it. And we have to change the image tag. We have to change the image tag, and this is not a chat, obviously. It's a key value storage service, and the image is 1.1.1. So we can see the service is running. You can see the logs coming out right from here, and in this window I'm in my root repository. So what I will do is I will run all the tests that I have in this repository, and so basically go test, and then the count says don't cache the tests, right, and rerun them, recompile the code every time you execute the command. And I can run the tests. Okay, what did I do? That's interesting. Okay. Yeah, so here we go. It took a couple of seconds. I don't know why. Maybe because it's a fresh branch. So as you can see, there are some logs, and I will unfortunately, I have to decrease the font size so you can see. But anyway, you can see that there are some logs coming out, and those logs are from our key value service from the Docker container itself. I will close this pane so you can see the logs clearly, and I will explain you a little bit. So for example, we have some endpoints, and this is basically logs coming from endpoints itself. So the tests, so what tests do is they execute all the API for all the client API, and the client interacts with a key value storage and puts some data into the storage, fetches some data into the storage, deletes data from the storage. And here what you can see is that, for example, I have some endpoints for echo, hello, and those are specific functions which you can invoke on the client side. So for example, the echo function, and I will go through the code in a minute, but I just want to emphasize the result. So for example, the echo function, what it does is you pass it as a string on the client side, and it makes a call to the server storage. It processes a string, so it may basically it's sort of the procedure to test the connection with a service, essentially, and hello serves the same purpose, right? So echo, you pass it a string and it returns you the same string, but all the uppercase letters replaced with lowercase letters, and all the lowercase letters replaced with uppercase letters. That's what it does. The hello function returns you the name of the service that you are talking to, and that's it. Then there are some other endpoints, and I will talk about them right now. So there are currently we can store 4 types of information into our key value storage. It's integers, floats, strings, and maps. And maps are of very specific type, so it's a map from string to string. I haven't gotten to the place where I implemented different maps, for example, from string to integer to float to maybe to an interface. I haven't gotten to the place yet. I'm pretty sure it's not going to be that complicated, but it will require some additional thinking, right? And yeah, as I said before, I have endpoints for integers. So as you can see, we can get the integer, we can put an integer, and we can delete an integer. Yeah, obviously they are so the put, get, delete, and get, and each operation basically modifies the state of the storage. So for example, the put will put element that you supplied on the client into the storage, and the get will get the element, delete will delete an element in the storage itself. Pretty straightforward, and I will go through the code soon. Let me see whether I'm still recording, and yes, I do. Okay. So the same for the floats, the same for the strings, and this is the key. The last element in the pass of our uniform resource identifier is the key which will be used in order to place the object into the map, right? Either it's an integer or string or even a map itself. So yeah, these are the logs that you can see. I will return back my window, and so I can shut down the Docker container and okay, no such container. I think it's service. Okay, so I stopped the Docker container, and let me go through the code briefly. Okay. So what I have here is, where do I start? Probably I will start from the service itself, right? So we have a main function which accepts a couple of parameters through the command line, and those parameters are the endpoint where you run your service, the certificates. The certificates are not used right now because the TLC is not enabled. I haven't tested that yet. I'll need to generate some certificates using OpenSSL, but that will come later. And the log level, for example, debug, info, warning, error, fatal panic, etc. There are multiple log levels that you can set, and you can disable the logs using disabled. Then I execute, and then I query the function setup global log level, which actually sets the global log level, and then you run the server. And the run the server function is inside the server.go, and what it does is essentially it creates a context, and then we console the context at the end. And I will, as I said before, this implementation is in progress. I haven't spent that much time on it, but it's getting somewhere. The final implementation would be to add to make a remote procedural calls to your key value storage instead of talking to instead of making like a HTTP requests, because this will be mainly used for communication between different services, and services don't need to encode the data. They don't need to send the data in plain text. They just can do it in binary, right? So gRPC will serve the purpose. Anyway, so I create an instance of our storage, and so this is like processing of some events, because I was implementing the transaction logger, and basically it's the thing that will log all your transactions into a separate file, so you can replay them later if your service crashes, right? If your service crashes for some reason, so basically how it works is that for every single hit of your endpoint, you write an event into the transaction log file, and then if the service crashes, you boot up the service again, and then you read from this transactions log file, and then you restore the state of your storage that was previously before the crash. So that's pretty handy thing, but it's still in progress. I will talk about it briefly if I have time, but it's still in progress. So I create a router, and this is I use the package called github.com, basically Gorilla package, which provides you some additional functionality on top of built-in HTTP package, not HTTP, I guess, that Golang provides you with. It has like the ability of specifying of using regular expressions for passes in the uniform resource identifiers, and you can specify methods directly, and you can create routes. So here I created a router, then I specified the parent pass, and here are the paths relative to the parent pass. So it's pretty handy. And then I register all those endpoints basically for the map, for the string, for the integers, for floats, and these are the two custom functions that I was talking about, echo and hello. And at the end, I log, and I will talk about logger briefly. We log that we're listening on some port and the address, and then we start the server using listen and serve, and this is supposed to be TLC, but I haven't implemented that yet, so no TLC yet. I will quickly jump to the logger, and then we come back to the service. So the log, I'm using Zerolog package, and I have implemented like a small wrapper around it. So it has the init function, which is basically invoked when the package is imported, and it initializes the map of the map from the string representation of the level to the Zerolog to the Zerolog level, right? So then you can query the function as I did in the main procedure here. Here a little bit about. So set up global level, and what it does is it calls this procedure, and we supply the string, and then it gets the Zerolog level, and then it sets the level globally, right? So you create, so any loggers that you will instantiate after this point will have the global level that you set up previously, right? And then I have a function for creating a logger, and that does some things like checks whether the underlying operating system is Windows. Then we do the login a bit differently. We use some coloring, and I can show you. Well, actually, I can show you now. No, I won't be able because the service is running inside the Docker container, not on the Windows machine, but anyway. And I provide some auxiliary functionality like panic, fatal error, warning, info, debug, so they are pretty handy. Let's come back to the server. So as I said before, we have some endpoints here, and what we do in the main function, we just call run server, and that's it. It's pretty simplistic. I have the struct, which is the settings, which is the endpoint, the path to the certificate, key, username, password. So, and these are the maybe I can go from the top instead of from the bottom. I have some imports here, and then I have basically the struct. I have one struct for each storage type. So for example, I have a struct for an integer storage, which has the map from the string to an integer, and then the mutex, read-write mutex, because the data can be accessed concurrently by multiple clients. So we have to provide it with a mutex, right? And we have the uint unsigned integer storage. This is not implemented yet. I will add the functionality in the future, but these things are. So for example, the float storage, we have the map from string to a float, and then have the read-write mutex. And the same applies about string and the map. So this will be the map to the map. The map from string to a map. And this is our common storage, which has pointers to all types of storage, and it has the transaction logger. And I intentionally made the note here that naming is hard, but the common abbreviation but the common abbreviation for transactions is TXN. I googled it on the internet because I got tired of writing transaction now all the time, so I decided to replace it with TXN. So anyway, it has like pointers to different types of storages, and this is where we initialize them. And then we have the CMD result. I will talk about it briefly a bit later, because each of our functions, I guess, returns the CMD result. And CMD result is basically the thing which contains the value, optionally the error, and the exists flag, which probably I have to rename to delete it, because this will indicate and the result of delete operation, whether the file existed before and whether it was deleted or not, right? So yeah, here are the helper functions for creating each type of storage, and this is the error, this is the helper function that I use, and here are like the core functionality, if you can say it. So it's pretty simple. You have like the put, the get, and the delete methods. And I will add in the future more methods, but this is just the core functionality that I have implemented yet so far. So what we do, for example, when we put some data, so this is the map storage, and what do we do in order to put data into the storage is we have to supply the key and the map itself, the value, right? And this probably has to be replaced with the value. Okay, so this has to be replaced with the value. We put the value into the hash map, and then we return the result. And then the same applies for the get, but we get the data from the storage, and if the data doesn't exist, we return the error, right? And then the same, if the data exists, we put the value, we assign the value, and we return the value. Delete, we we provide the hash key, and then we delete the data, right? And we check whether the data existed before. If it did, and we return the result of whether the data existed before or not. We'll need it on the client side, because when the client calls the operation, for example, map delete, that will return the bool cmd command, and that bool, and then you can check the result of that command in order to differentiate between whether the data existed or not. So the same operation for each type of storage, for strings, for integers, for floats, for yeah. And then I string put. I should have probably rename it to string str put handler something. These are the handlers that we hit our endpoint, and then we invoke the callback, the handler, which should have a specific signature in Golang. The first parameter goes to the response writer, and this is essentially the stream where you write all your response, and this is the request, the pointer to the request that came from the client. And I log here, and this is essentially all the logs that you've seen in the demonstration, right? So all right, I log at each handler, so I specified endpoint and the method. And I'm not going through every single handler, but I will go briefly through maybe one of them. So what we do is we receive some variable, we get the variables from the request, and basically Worth returns the route variables for a current request, if any. And I told you before that, for example, here I specified the key, which can be of arbitrary, not really, because we have a regular expression which expects the range from 0 to 9 digits, a uppercase to z uppercase, and a lowercase to z lowercase, and underscore, right? So this is the range of the letters that we, alphanumeric letters that we that the key can represent. But then we can refer to that key, whatever it was here, by the key value itself. And that's what we do. And this is like the functionality that the Gorilla package provides us with, right? So we get the variables, and then we make a lookup for the key, and then we use that key as a value as a key in our map in order to store the data, right? So we get the key, and then we pass the key to the get function, and the get function is the member function of the string storage in this case, for example. So we pass the key, and that we just make a query, we just make a lookup in the map, right? And then we check if the key existed, we proceed further. If it didn't, we call the HTTP error function, and it basically reports an error to the caller, and in my case, status not found, and I write the error, and the error will be this type of error here, this type of message here, right? Which will contain the key and the message itself. And if the key doesn't exist, we report an error. Otherwise, we convert the value to the bytes, and then we add some headers here, like content type and content lengths. I'm not even sure whether they are necessary, because Gorilla will do everything for us. I guess they are added automatically. But anyway, just for security, I will add those things just to be sure. And then we write header status OK. This is like, I'm sure it's not necessary, but to be explicit, because write function does it implicitly. So what we do is we write status OK, and then we write the bytes to the response writer itself. And then this line, and I will talk about it very briefly because I haven't implemented yet. I only sketched out like the functionality of the transaction logger and the events itself. And I will give you the book where you can read more about it. Yeah. Yes, so this is the thing which logs all the transactions, writes them in the transaction logger file, right? Then we have a delete handler which fetches the key, which came from uniform resource identifier URI, and it gets the key, and then it does the same if the key, if we fail to delete, which is very unlikely, I would say, because currently it doesn't return any errors. It returns a structure, but the structure doesn't contain any errors. But this is just to align with an API that I have, right? So yeah, and this is, I think, important because, for example, we check whether the value existed, and if it does, if it did before the deletion, we add the header deleted and we set it to true, and later on the client side, when we receive the response, we process that header and we say, okay, if the value was deleted, then we set the flag to true. Otherwise, the flag would be to false, which will indicate that the value, that the delete operation didn't actually modify the state of the storage because the data didn't exist, and that's why like delete had no effect at all. And then we do the same, we write header. I decided to actually use the status no content here. I googled, there are multiple statuses that you can use as a result of successful delete operation. For example, you can return as well status OK, or you can return accepted, or you can return, for example, status no content. I decided no content for some reason, and again, I do the logging here. And the same applies to every type of the storage. Some might be tricky, especially, for example, with a map, because with a map you have to, and this is the echo function. Let me quickly find the map so I can scan through it. Yes, for the map we have to marshal the JSON that we received into bytes, and then we have to okay, no, I'm wrong here. This is actually the get. Okay, so we get our map, yes, and then we marshal and we produce the bytes, and we send that bytes over the HTTP, right? So that's correct for the map. For map put, we unmarshal the JSON. So these like the things that you have to keep in mind. Now I can go to the client. And I will talk about client a bit. Yeah, I haven't added retries yet, but essentially, and yeah, it's a bit tricky, but in a nutshell, the client has like multiple callbacks, and those callbacks are invoked on each command, whether it's like, maybe I can show you the API first. So these are the tests, and for example, I have tests for the echo function, and you can run them on your own. So basically what you need to do in order to run all the tests, you have to spawn the Docker container again, right? And then in order to run the tests, you do test and then the count one, right? Better. And that will execute all the tests in the repository. All the tests here, right? Or you can run them manually. So I executed the Docker container, and in the Visual Studio you can just say, okay, run the test, and that will run the test for you. But they are cached. You have to be careful that Visual Studio caches the tests. I don't know how to disable it yet. But anyway, so we have the hello test for hello and echo endpoints, and then the integer round trip, and the float. Oops, I didn't mean to debug the test. We don't need that now. Okay. So integer round trip. So this is the test for actually storing integers in the remote storage, key value storage. This is for floats. So the API looks like this: int put, int get, int delete. For the float, it's f32 put, f32 get, f32 delete, and the string the same, and the map is the same. Like very simple, pretty like understandable, nothing special here, and it works. So this is the task for the map. And what the client does is, it's a bit tricky, but I will try my best to explain. So it has the client and the settings, and it has the callbacks. So the callbacks are the functions which are invoked on every single command on every single API call. So for example, when the user calls int put, for the callback for integers will be invoked. And callbacks sorted not by the commands, they are sorted by their return value. And if the callback takes an integer command, and this is the struct that you can see probably here in SIMD. The callback will take the insim struct, and the callback will return the struct as well. So, and all the and I somewhere maintain the map of all those things. Yes, so I have the command group which has the map from a name to all the callbacks. So I have the like the table for int callbacks. I have a table for callbacks which take the int result, and return the int result. I have the table for callbacks, which takes the string result and returns the string result. The same for the map, the same for float, and the same for boolean, right? And then I have the global variable, the pointer to a cmd group, which is this struct up here, and this is the function that I use, which initializes basically the cmd group. And this is the init function, which will bind all the callbacks. So for example, I have when the user calls an API in get, eventually the client will call this function int get command. And this is this function up here in the same file, but a bit below. You can go through the code like on your own after this and explore the code, what it does. But this is essentially all the functions, all the callbacks are here. And then when the user calls echo function, the echo command will be invoked. So it's basically like a vtable from the name to the function pointer, which will be invoked, right? And yeah, and then we have like a new client, which initializes the client. This is the API function that the user is supposed to use, and this constructs like the base part of the URL, the schema, and the I don't have the the domain, and then the pass. The base pass, and the base pass contains the API prefix and the version of the service, and the version of the service is declared here. So this is like the version number, and since I cannot, I think, pass dots, include dots inside the URL, I just replace dots with dashes, and this is what this function does here, right? Pretty simple. And then I have some API functions for retrieving the result of each command. And if I go to the test, I can call you briefly. So I can show you briefly. So we call strput, and it returns the put result, and the put result is of type int_cmd pointer, right? And then you can query multiple, then you can invoke multiple methods on that result. You can check the error of the result, you can get the result itself, and yes, like for example here, and you can get some arguments of the result, and you can get the status code, you can get the status message, etc, etc. This is the helper function that I use in order to fill in the arguments. And these are the functions that I use to create an instance of each struct: the map, the string, the boolean, the integer, and the float. Right? So here they are, like the struct for each command result, and this is what will be returned to the user, right? And each of those structs will contain the result. So if the user wants to put the map into this remote storage, this will be returned to him, right? And which will contain, so let's assume that the user invoked the function put map into the storage, and somewhere later in the code he invokes get map, and he will receive this result, which will contain the map. And in order to get the map, you would have to call the result function, which will give you the map itself. I assume that is pretty straightforward. And here are some helper functions to create those things, as I said before. And here are handlers for the echo function, not the handlers, but the API for the echo function, for the hello function, and for all the other things, right? So the API is listed in one place. And what it does is just we define the name, because that name will be used in order to invoke the callback in the callbacks table here, right? So the name here and the name here has to match, because otherwise we will invoke nil callback, or callback which is not defined, which is the runtime panic. So I add some arguments. So the argument will contain the echo function, and the argument will contain the value, and then I pass them to new strcmd in this case, which will just accumulate all the arguments, and then I invoke the callback inside my table. And in this case, what I will do, so since this is the echo, I will invoke echo command. So this callback will be invoked, right? Which unpacks the arguments, which gets like the name, and we construct the pass from the name, and gets the value, and this is the value that the client supplied, right? So for example, here I have a task for the echo function, and this is the value that I pass here to the echo function, and this is how I get the value. I just cast the argument number 1 to the type string, because I know that this argument is of type string. And then we call make HTTP request. And what make HTTP request does is exactly what it says. It makes the HTTP request. It parses or constructs the URL to make sure that all the pieces are correct, the schema, the domain, the pass, the query, etc. I don't have query, but like it joins the pass with the pass that you specified here with the base pass that was initialized when we created the client. Let me take a look. Okay, so I have been talking for 41 minutes. Crazy. So yeah, as I said before, we invoke make HTTP request, we pass the client, the context, and the HTTP method, and we pass the buffer, and the buffer will contain the value that we will include into the request body, right? And it will return the HTTP request result, which will contain the bytes, which is the contents of the body, of the response body, and some additional data, which is the status code, the status, and the error. And yeah, let me jump again. So here what I do, I check whether the context is nil, and this is a bit hacky. I like documented it here, why I did the way it is currently, because I was getting some unexpected behavior, and anyway, I'm not gonna touch it right now because it's out of scope, and I will focus on the implementation detail rather. So I call HTTP new request with context, and I pass the HTTP method, the string representation of our URL that we parsed, and the contents if we passed some contents in case of put method, but in case of get or delete, we don't have to pass anything, right? So this function will be invoked. And then we do some processing, set up some headers, and the user agent, and then we do the request here by invoking the do method on the client itself, and so this is the documentation. You can go through it if you want, you can read it, and like the most important part for me is that it doesn't treat any response which is different. It doesn't treat the response status, which is different from 300, as an error. So the error only will appear if it was some connectivity issue or some other, like a connectivity problem with a network, or failure to speak HTTP, or the client policy, etc. But the status, for example, not found, or internal server error doesn't cause this function to fail. So that means that we'll have to handle it separately. And that's what I do here, right? I check whether, and this is essentially the check for the client error. Whether the client error occurred, we return the result. If it doesn't, we set the status code, and here we check basically some things, and this has to be aligned with the server. So, for example, I told you before that for the get method, and this is how I decided to structure my API, or REST API, if you want to call it like this. For the get request, if the resource is not found, I return status not found. And that's what I parse here, right? And the body will contain the error message. So here I'm trying to retrieve the error message and assign to the error as a new error, right? And return. Otherwise, if it's method delete, I check the deleted header, and if it has, I assign the contents. And yeah, basically, if it doesn't have a deleted method, that would mean that that delete had no effect. It didn't delete the resource because the resource didn't exist before, right? And then if you have an HTTP GET method, what we do is we read the body, and then we assign this body to the contents, and we return the result, the result which contains all the fields that we filled in, right? And let's take like function for, maybe not for the map because it will be more complex, but for the integer, for example, we made a request. So this is the get request, okay, get request. And then we set all the things, like, because CMD status is additional struct, which contains the status, which basically the embedded structure, which contains the status code, the status, and the error. And then we assign all the fields that we specified in the result to our result that will be returned to the user, right? And here we check if the error occurred, then we just return the CMD, which will contain the error because it was assigned here. Otherwise, we need to fill in the result field, and the result field for an integer result would be an integer because we are getting the integer from key value storage, right? From the remote key value storage. And that's it. We have to convert our contents to the string, and then we have to parse that string into the integer and assign to our result, and then we return the result. We return the result to the client, and let me find, so int get, we return the result, and we check that no errors occurred, right? That's correct. And then we check that result is equal to our value that we have supplied in the beginning. So let me go through one test so it's clear, like, and you clearly understand what is happening. So the Docker container is running currently, right? I have built the image, run the Docker container, so it contains the key value service. And I guess it would make sense to go through the Docker file. So this is the Docker file, which contains like the main, which contains of two stages: the build stage, where we build our key value storage, and the run stage, where we copy all the binaries to the lightweight image. And this stage wouldn't include any source code from the previous stage, and we run it on the port 8080, right, locally. But that would be actually inside the Docker container, obviously. So the Docker container is running currently, right? And maybe I can, let me close this window, and what I can do is I can do this so we can see what's happening a little bit like this. Let me close this part. Okay, so let me debug this test for the integer. So what we do is we yeah, let's give it a minute. Yeah, so what happens is that we create a client, we create a cancel context because it's necessary, and we put our value into the remote storage. So oops, I didn't expect that, the breakpoint here, but as you can see, we put the put endpoint was invoked for the integer, so it's int put and the method put, right? And then we return, and we return the result. And the result, put result, will contain the result 0 and the arrow code, these are the arguments. The error is 201, which is created, and the error itself will be nil, which is correct. Then we get the integer, we execute in the get API call, and as you can see in the logs on the right side of the screen, we managed to hit the get endpoint for an integer, and the get result will contain our integer that was stored in the key value storage, right? That's it. And then we make sure that the result is correct, and then we execute the int delete procedure, which will delete here, which will delete our element from the storage. And here we make sure that actually the result is true, which means that the value was deleted, it existed before, and it was deleted. And here I execute get command again to make sure that the value doesn't exist. And in this case, the get result will, and you should always check for the result, will contain the error not found, because this is what our API defined. This is what the server sent, and the error message will contain the message itself. So key ID not found in integral storage. And this is exactly the message that came from the server that I showed you maybe a couple of minutes ago, right? And that's it. That's it. So nothing special. Server. Okay, how do I... Okay. Yeah. So this is the application and the key value storage. There are a lot of space for improvements, and that's what I will be doing a bit later. But essentially, I want to use the storage in the chat application that I was writing. And as you can see here, I have the Redis backend, which I have implemented. It has a lot of to-dos because obviously I have to polish some things, but I have added the KFC package as well, and that would be my implementation of the key value storage. But I will go through it later, and it has you can run it in the Docker and use it as a real chat, and I will go through it as well once it is implemented, because it has some interesting things. I have organized it as a state machine, like one giant state machine, which has some cool features, which has some benefits, has some drawbacks, but it simplifies the processing of the user data. That's it, I guess. I hope you enjoyed it. Thank you for watching. And again, I will put the link in the description so we can explore the code on your own. Yeah, and have fun.